Hello students, this is problem 3 of the Leibnitz formula series. Now it is given that y is equal to sine of m sine inverse of x, and they are asking us to show that 1 minus x squared multiplied with yn plus 2 minus of 2n plus 1 multiplied with xyn plus 1 plus m squared minus n squared multiplied with yn is equal to 0. So now in order to prove this, first we will consider the y which is given, that is equal to sine of m sine inverse of x. Now first we have to find the first derivative of this. So when we differentiate this with respect to x on both the sides, what do we get? We get the differentiation of y1 as y as y1, that is equal to the differentiation for sine of any term is cos of that term. So differentiation for sine is cos of the term which is given, m sine inverse of x. And then we have to do the chain rule method, where we have to differentiate whatever is given inside the bracket. Now this m is a constant, so we will multiply it, multiplied with the differentiation of sine inverse of x. The differentiation for sine inverse of x is 1 by square root of 1 minus x squared. Now this term we will take it to the left hand side by cross multiplying, and so we will be getting it as square root of 1 minus x squared y1 to be equal to m cos of m sine inverse of x. Now in order to get rid of the square root, we will square on both the sides. So squaring on both the sides, what do we get? We get, so the square of the square root is the term itself, so 1 minus x squared multiplied with the square of y1, which is y1 square, equal to the right hand side also we have to square. So the square of m will be m squared, and when we square this term it will be cos square of m sine inverse of x. Now by using the trigonometric formula, we know that cos squared theta is 1 minus sine squared theta, because sine squared theta plus cos squared theta is equal to 1, and so cos squared theta will be equal to 1 minus sine squared theta. So this will become 1 minus x squared multiplied with y1 squared equal to m square multiplied with, as I told you, cos squared theta is 1 minus sine squared theta. Now here we will be having 1 minus sine squared. Instead of theta we are having m sine inverse of x, so we have to write that. So m sine inverse of x. Hope you have understood this. And then this will become 1 minus x squared multiplied with y1 squared equal to m squared multiplied with 1 minus, and when we check out for this term, it is actually y squared, because our y is sine of m sine inverse of x, and so sine squared of m sine inverse of x will be y square. So this can be replaced as y square. And now we have to differentiate both the sides again with respect to x. So differentiating both the sides with respect to x. So when we differentiate, we have to use UV method here. So first we will consider this as such. So 1 minus x squared multiplied with the differentiation of this, which is the differentiation for y1 squared is 2y1, and then by chain rule we have to differentiate y1 whose differentiation is y2, and then plus y1 squared, we should have it as such, multiplied with the differentiation of this term. So the differentiation of 1 is 0, and the differentiation of minus x squared is minus 2x. Okay, and so that is equal to, now on the right hand side m squared is a constant, so we will have it as such, multiplied with, now this one when we differentiate it will be equal to 0. So we have to differentiate this term, so minus the differentiation for y squared is 2y, and then we have to use chain rule and we have to differentiate y. So the differentiation for y is y1. It is because y is a dependent variable, whereas x is an independent variable, and we are differentiating with respect to x. That is why we are applying the chain rule here, and so the differentiation for y squared is 2y, and then the differentiation of y, which is y1. Now if you check out, in all the three terms 2y1 is common. So we are going to divide by 2y1 on both the sides. That is, we are going to divide throughout. So in the first term, when we divide by 2y1, this 2y1 will get cancelled and we will be left out with 1 minus x squared y2. And then plus into minus is minus. Now here when 2y1 gets cancelled, one of the y1 is left out here, and so this will become xy1. So xy1 is equal to, now here we are having the negative sign, and m squared, and 2y1 will get cancelled and we will be left out with y, because we are dividing by 2y1 throughout on both the sides. So this will be minus m squared y. Now let us take this minus m squared y to the left hand side, and so we will be having 1 minus x squared y2 minus xy1, and when this comes to the left hand side it will become plus m squared y equal to 0. Now we have to apply nth derivative on both the sides. So applying nth derivative on both the sides. So when we apply the nth derivative, we will be writing this as d power n of 1 minus x squared y2. Similarly, minus d power n of xy1, and then plus d power n of m squared y is equal to 0. Now let us mark this as equation Roman letter 1, and this is term 1 which we have to evaluate and substitute here. This is term 2, again we have to evaluate this and substitute here, and let us have this as term 3. Then we have to find all the three terms separately and we have to substitute here. But if you refer our previous problems, you can see that we would have already found the value of this and this as well, and then we will just directly take it and substitute here. So in our problem 1, I have given the detailed explanation of how to find the nth derivative of 1 minus x squared y2. So that is what we want here, 1 minus x squared y2. So if you check out for that, you can see the detailed explanation. The link of this problem I will give in the description box. So finally we have found it to be this. And then I have also found the nth derivative of xy1 in the same video, and we have marked it as equation 2. So that is what we want here, the nth derivative of xy1. So anyway, I will be giving that in the link of that video in the description box. You can view and you can get the detailed explanation of how to find these two. Now after finding all the three separately, I have written it here. So this is the term 1, the term 2 and term 3. Now we will substitute all the three terms together. So the required solution will be 1 minus x squared yn plus 2, and then minus 2nxy n plus 1. And then this we will multiply inside and we will write it. So minus n squared yn, and then minus into minus is plus n yn, and then this term. So we are having a negative sign, and so though both the terms will become negative, xyn plus 1 minus nyn, and then we are having plus nth derivative of this, so it will be plus m squared yn equal to 0. Now if you check out here, we could see that these two terms gets cancelled, that is plus nyn and minus nyn gets cancelled, and finally we get this to be 1 minus x squared yn plus 2, and then in these two terms xyn plus 1 is common and the negative sign is also common, and so it will be 2n plus 1 xyn plus 1, and then if you see here, these are the two terms that we have, and we check out that yn is common in both the terms, and so we will be having it as m squared minus n squared yn to be equal to 0. So this is what we are required to prove. So hope you have understood this problem. So hence we have proved the required result. Thank you.